Today we want to talk about scientific notation. Scientific notation is simply a way of writing numbers in science that are possibly really annoying to write because they have a whole lot of zeros either at the beginning or at the end. So it just makes it a whole lot quicker to write it in this method. Scientific notation always consists of a number with only one non-zero digit to the left of the decimal, and it's then followed by a power of 10. For instance, 2.5 times 10 to the 7th, or 3.62 times 10 to the negative 4th. One of the big things we want to realize is that if we have a positive exponent, if that exponent is positive, then that is a number bigger than 1. So it's a large number. If we have a negative exponent, a negative exponent means that that number value is smaller than 1. If you will remember that, you don't have to memorize things like, well, you move the decimal to the left if it's negative or right if it's positive or anything like that. You just have to know what kind of number you're dealing with. For instance, in this first value, I want to just look at the number and decide, is this going to have a positive exponent or a negative exponent? If I have 45 million, well, hopefully we realize that that is much bigger than 1. When we get done with this value, it is going to have a positive exponent. 325. Again, is this number bigger than 1 or smaller than 1? Since it's bigger than 1, it is going to have a positive exponent when we get done with it. The number 0.000150, is it going to have a positive or a negative exponent? Since it is much less than 1, it is going to have a negative exponent. The next value, obviously much less than 1, it is also going to have a negative exponent. So just by looking at these number values, we can tell that. Going over and going in the other direction, since this particular exponent is a positive exponent, we know automatically it's bigger than 1, and we're going to move the decimal to make sure that when we get done, that number is going to be bigger than 1. And our 6.330 times 10 to the negative 3, since it's a negative 3 for the exponent, we know that this number is going to be smaller than 1. And when we, again, move that decimal, we're going to make sure that when we move the decimal, it is smaller than 1. The next thing we want to make sure is where the decimal needs to, where we start the decimal if it's not showing, and where it needs to get moved to. So let's put in our decimal if it's not showing. If the decimal is not showing, we know that the decimal comes in at the end of the value. So I'm marking all of those decimals. If it's showing, we obviously know where it is. But if it's not showing, it's at the end. The next thing that I want you to do is to mark where the decimal needs to be moved to. Remember, we want only one non-zero digit to the left of the decimal. So that means if I want only one non-zero number to the left of the decimal, I need to move it to here for that 45 million. One number to the left of the decimal on the next value, I want it moved here. On the next value, only one non-zero digit. The next value, one non-zero digit. So I want to make sure that I'm moving the decimal to the correct position. I'm also going to be paying attention to sigfigs. I want to make sure that the number of sigfigs in my value that I start with is the same when I change it to scientific notation. The beauty part of scientific notation, all digits in scientific notation are significant. I'm going to abbreviate that. All digits in scientific notation are significant. A little bit ran out of room there, but you know what I'm talking about. So I'm going to mark the sigfigs. Now we're marking sigfigs with the original number. So these first two, we're going to ignore that decimal. So on these first two, the 4 and the 5 is significant, but since those ending zeros, there's no decimal showing in the original number, we're not going to, they're not significant. So there's only 2 digits or 2 sigfigs in this value. All 3 of these are significant since they're all non-zero numbers. In this next one, The beginning ones, the leading zeros, the beginning zeros are never significant, so those don't count. The 1 and the 5 are significant. That ending zero, since the original number had a decimal showing, it is going to be significant as well. And finally, in the last one, none of those beginning zeros are significant. They never are. So the only ones that are significant are the 2, the 6, and the 8. So we've marked our sig figs. We've got these values ready to go to change them to scientific notation. So I'm going to write these values down, keeping the sig figs, moving that decimal the place I said I was going to move it, 4.5 in this case. I'm going to drop any zeros that are not significant. We've already said this is going to be times 10 to a positive exponent, and now we count the number of places we need to move the decimal to get it where we want it to be. So it's starting here, 1, 2, 3, 4, 5, 6, 7. I need to move it 7 places, and since I've already said it's a number greater than 1, it's going to be a positive 7 for that value. In the next number, well, try the next number yourself real quick and see what you get. Okay, hopefully you notice that we need to move that decimal between the 3 and the 2, so there's only one non-zero number to the left of the decimal, so we write those values down. Now let's see how many places we have to move the decimal. It started where this blue dot was, so 1, we need to move it 2 places to get it to that position between the 3 and the 2. We've already established it's a number greater than 1, so times 10 to the positive 2. Now look at the next one. How is it different? We're still going to keep all of those sig figs, the 1, the 5, and the 0. We know the decimal needs to get moved between the 1 and the 5. We've already established that. And to get that decimal to move, it's 1, 2, 3, 4 places to get it to move to the correct position. And again, how is that different? It's different because the original number was less than 1. And what did we say that meant? It meant that there's going to be a negative 4 for that power of 10. Now in our next example, again, try that one yourself real quick before we get the answer. And hopefully you came out that it is going to need to be 2.68. We're going to keep all of the sig figs intact. And when we move that decimal, we need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And since that original number was less than 1, it's going to be times 10 to the negative 9th. So there's how you change those number values to scientific notation. Now what if you need to go the other way around? What if you've got it in scientific notation and you need to change it to regular notation? Well, first of all, we've got the decimal. Scientific notation is always going to have the decimal showing. All of the digits are significant, so we've got to make sure we keep all of those significant in our final answer. We've already established that this has to be bigger than 1. And since it's a positive exponent, bigger than 1, in order to get this decimal moved 5 places, think about it. If we moved it to the left and came up with a decimal value, yeah, not going to work because that number is going to be much less than 1. We need it to be bigger than 1. So using common sense, we know that the decimal has to be moved 5 places. 1, 2, 3, 4, 5. Replace those with 0, 5 places to the right in order to make it a big number. Now, I get this. Don't write this down yet. I get this all the time. People write this down. And they keep the decimal in that position, but think about what we're doing. The whole purpose of this is to move that decimal to a different position. So we've got to move that decimal to a different position down to here. But now remember what else we said. We need for this to have the original number of sig figs, 3 sig figs. This is very similar to one we did in a previous set of notes where we had to create 3 sig figs. We know we can't keep that decimal because if we do, all of those digits would be significant since the zeros would be significant since there's a decimal showing. So we know we've got to get rid of the decimal. And how's the only way we're going to get 3 sig figs out of this? We know the 9 and the 7 are significant, but we also need that 0 to be significant. What do? Hopefully you remember we need that bar over the top. So the answer to this value is 970,000. So try the next one real quick, keeping in mind, again, all sig figs are, all the digits are sig figs when we're dealing with scientific notation. So all 4 of those have to remain significant. So try that really quick. Hopefully you noticed that since it's a negative exponent, we need to make this number smaller than 1. So this time we are going to need to move this decimal 1, 2, 3 places to the left to make this a smaller value. So 0.006330, a couple of things. We need to keep that ending 0 because it's significant. We can't get rid of it. These first 2 zeros are not significant, but in class we've discussed the fact that you cannot write a decimal value in science without putting a 0 in front of it. So please make sure that you keep that 0. All of these beginning decimal values, these beginning zeros, are not significant, but all of these are. That ending 0 is significant because there's a decimal showing. So that's how you would change those values into regular notation.